All right. I think we're up and ready to go. Well, hello everybody. Yesterday I live streamed for 2 hours, and yeah, I forgot to click go live, so none of it got saved, and wasn't able to upload it, which sucked. But anyway, yesterday, like the title says, we're going to be building a linked list using the TDD method of development. TDD stands for test driven development. So that's what we're going to be doing. And let's get her started, I guess. Gotta start all over. I mean, this is going to be a long a long stream. So if you know what? Can I change the title now and just put like long stream or something? Edit. This will be a very long stream. There we go. And save. That should have updated that. I hope it did. Okay, cool. Coolio. Let's see. All right, I'll switch to this. Looks like I'm getting some green screen action over here. That might be, yeah, it's this side. Okay, that's better. All right, let's see. So let's open up some VS Code. VS Code. I don't know what's going to pop up. So let's move over. Oh, this is just my little prime numbers thing. I can show this. It's no big deal. All right, let's create a new file. We're going to call it... let's call it... Actually, let's create a folder. Let's create a folder. So... let me delete the old folder. And let's see. I'll just get bash here. And then we will make a directory. We'll call it Python tut, I guess. And then we'll cd into that. Oh, cd back. cd into Python tut. All right, and then we will create a so we're going to be creating a doubly linked list. A doubly linked list means every node in the list has a reference to the next node and the previous node. All right, so let's I guess create a dll.py, and let's create a test dll.py. Oh, and we're going to need a node.py because we're going to have to create nodes. Should we build a test? No, we'll just have one test file. Okay, cool. So we have that. Now let's open that folder. Python tut, like so. And let's get to it. Well, actually first, just in case some of you people aren't aware of what a doubly linked list is, which I'm sure you do if you're watching this video. We'll just go to linked list. Should be a wiki page. Yep. So this is a linked list. You have a node, you have a reference to the next node, you have a node, you have a reference to the next node, and then you have a reference to nothing. We're going to be building a doubly linked list, which is a little easier to manipulate. This one's got two references, a previous and a next. Previous points to nothing on the, this is called the head. Next points to the next node, previous points to the node previous to that, so on and so forth. And then the last one, the head points to the node before that, and the tail, this is called the tail. The tail, this node is called the tail. The tail next node points to nothing. Then you have a circular one where the tail of the next to the tail node points to the head node, and I think there's a doubly circular one or something like that where the head points to the, I don't know. There may not be. But anyway, here's the time of complexities of a linked list. If you want to screenshot that or whatever, you can, or just go to the wiki, it's there. So this is essentially what we're going to be building, and this is code. So okay, we're building a doubly linked list. I'll go ahead and close that, and we start off with our tests. So let's import, what's it called? I forgot. Unit test. Import unit test. We want to make sure that if the name is equal to main, we want to go ahead and call call main. So this way, when I run the file, it immediately it'll immediately run the file. It won't I won't have to pass unit test into my command. Alright, so let's see if that does anything. Boom. Ran 0 tests in 0 seconds. Everything's looking good so far. Now we need to create a new class. This class is going to be called test DLL, like that. It's not going to have, oh, actually it does have a reference. It has a reference to unit test dot test case, like so. And then we're going to have a setup. Setup. Set up. Why is it not doing that? Maybe because I got to save. Now let's try it. Def setup. Huh, interesting. I thought that turned a different color, but maybe it doesn't. And we want to, duh. Got to reference self. That's what it was. We want to create the DLL in setup. Setup will run each time on each test. So self.dll equals, and then we're gonna say DLL. I guess we'll just do capital D. No, we'll do it like that, right? No, we'll do it like that. DLL. Okay, this is not going to pass because, well, I thought it would throw an error, but I guess I need to create a test first. So now we're gonna test what? Test DLL created, right? Test DLL created. Does that make sense for a first test? I think so. So, was self dot assert true, and then we're just going to say self dot DLL. Is it true? Is it created? Is it a thing? Let's run the test. And it failed. Let me move this. Let's see, let's move this here. You can still see everything good and Gucci. Let's move panel right. I don't know what that is. Let's try running it again. Okay, there we go. Alright, so now you can see it says name DLL is not defined. So it's because I tried using it here, and this is nothing. It's line 5 and setup. Boom. Okay. So we need a DLL class. In order for that to work, let's go ahead, and we know we're going to be importing from DLL import DLL, like that. Right? Look good? Yeah? No? Looks good to me. Alright, now we want to create a class here. We're going to call this DLL. This isn't going to reference anything. And let's just pass. There we go. Ran 1 test. Okay, so that passed. So that did exactly what it was supposed to do. Alright, so now we need to break down what a doubly linked list has. Let me open up that web page again. I closed it like an idiot. Control H is history, like list, Wikipedia. All right. Doubly linked list. So this is a node. We have a node. Oh, this is a node. Okay. Doubly linked list, not node. I'm over here trying to explain a node. Doubly linked list. This is the list. Okay. In the list, we have a head. We have a tail. And we can or can't have a length. Is it? All right. So we want to run a test. Def test. Let's just test it in created. Self dot assert true. Self dot assert true. Self dot dll dot head. I'm thinking, should I just? Nah, I'll do it separate for readability. Self dot assert true. Self dot dll dot length. And sorry if you hear the dog. Self dot assert true. Self dot dll dot tail. So we should have a head, a length, and a tail. And we're gonna fail because we don't have those. DLL object has no attribute head. So let's give it a head. How do we do that? Well, we have to create a initializer method called init. We pass in self, and then we give it a value. No, that's a node. We give it a head, we give it a tail, and we give it a length. Okay. Length is going to be defaulted to 0. Tail is going to default to none. Head is going to default to none. And then self dot head equals head. I think that's the first one. Head. Okay. Now let's run it. None is not true. DLL.head. Assert true. Self.dll.head. Trying to think. What's the best way to do this? So I just defaulted them all to none. Right? If I add them and I don't default them to none, then that means I have to put arguments into the doubly linked list. What if I don't want to put arguments into the doubly linked list? Actually, we don't want to add this length here. We don't want to add the length there because it's getting hot. We don't want to add the length there because then that means we have to add the length should be dynamically updated. So that shouldn't be added in there. We should just be able to add a head and a tail. Or I could just make it so that the DLL, whenever you create the DLL, it's empty, and then we just have these. They could be set here so you don't. Well, that's the same thing. I guess that's the same thing. Because down here I would say head, blah blah blah. Here I guess if you wanted to give it a head and wanted to give it a tail right off the bat, you could. Trying to think. If I give, say for example, I create the DLL, I give it a head, and I don't give it a tail, then that means I have to create logic for when the head, when it's created, if there's a head and there's no tail, then assign the head to the tail. And the same thing, if there's a tail but there's no head, then assign so on and so forth. What I could do is just, I could say node equals none. I could default node to none, and then I could say self.head equals node, and then it would be the same thing, self.tail equals node, and then self.length length, if I can spell that right, equals 0. Well, it wouldn't be equals 0 because yeah, it wouldn't be equals 0 because if I add a node in there, then this would be 0, and that wouldn't work too well. So for simplicity's sake, I'm sure there's use cases for that and stuff, so I'm just going to omit that altogether, and I'm going to say, I'm just going to set these to, I'm going to make it so that you can't add, you just create the DLL and you can't add any nodes yet, right? Makes sense? Okay, so now this assert true is none, equals is none, and then this, I did this wrong, equals 0. Okay, so that worked. This, if I do equals 1, it should fail. Yep. Okay. All right, cool. So that was exactly how it should have been. All right, so now we create the doubly linked list. It has a head. It has a head property, it has a tail property, and has a linked property. What do we need next? It'd probably be a good idea to create a list of what we need. So as far as the DLL goes, what does the DLL have that we need to create? So the DLL has a and let's see, we have a add node to head, right? We have a add node to tail. We have a remove node from head. We have a remove node from tail. We have a delete node. We have a so we have a length. Let's see, what else could we do? What else would we do? Let's check the wiki and see what all features a doubly linked list should have. Let's see, basic concepts and nomenclature. Element or node, the field each node that contains the address of the next node is usually called the next link or next pointer. The remaining fields are known as the data, information, value, cargo, and payload fields. The head of a list is its first node, the tail of a list, blah, blah, blah. What operations are commonly used on a linked list? Let's see. Linked list operations. Our node data structure will have two fields. We're not worried about the node yet. We want the list. Traversal of a singly linked list is simple. The following code inserts a node. Insert after, insert beginning. Those we would do on the node itself, not necessarily. See, like this, remove beginning, remove after. Insert beginning, insert after. These are all node operations, not list operations. So I guess what does the list do? What's the purpose of the list? Adding and removing nodes. So that's I guess that's what we'll focus on for right now. So we'll just worry about add node to head, add node to tail, remove node from head, remove node from tail, delete node, and insert node. Insert node. So let's see. If you wanted to insert a node, I guess insert after would be insert after, insert before. Right? If you have a list and you wanted to put a node after another node, you wanted to put a node before another node. Say you had a node with a value 4, and then you wanted to put that 4 before a 5, so you had to iterate through, find the 5, and then place the 4 before the 5. Or if you had a 6, place the 6 after the 5. So insert after and insert before would be valid methods to go on a doubly linked list. Node to head, node to tail. Those methods are specifically head and tail because when you do that, you have to update the head and tail of the list. You can do that in the other methods, but it just adds extra, like, you know, the blocks get bigger and stuff, and it's just not very pretty. All right, so what are we going to do first? We created it. Now let's add a node to the head. So we go to our test here, create a new test, def dll. We'll just say add to head self, and then we need to create a node. So node equals node, right? Node equals node, and then we know that we need to say self.dll dot add to head, and then we pass in that node, right? And then we would say self dot assert true, self dot dll dot head, and then that should equate to true. And yeah, so self.assert true, self.dll.head. If we run this, it shouldn't pass, which I know it won't. Node is not defined, so we need to create a node. So we know we're going to have to import it, so let's import from node. Let's go to node. Let's create a new class. We're going to call this node. References inherits from nothing. Pass. It's good. Good. Now let's run it again. Now it's a different error. So success. DLL object has no attribute add to head. So now we have to create an add to head method on the doubly linked list. So let's do that. Def add to head. We're going to reference self and receive a node, and then we're going to say self.head equals node. Basic, very basic. Let's run the test, and ran 2 tests. Okay, awesome. So now we add it to the head. We want to make sure that it updates the length. Self.assert true, self dot DLL dot length equals 1. We add it to the head, the length should equal 1. That's going to fail. False is not true. Let's change this to assert equal. False is not true right off the bat. Doesn't really sound too understandable. So assert 0 does not equal 1. So what does that mean? Our length isn't being updated. So let's go back to DLL. Self.head equals node, and self.length plus equals 1. That should pass the test. And bada bing, bada boom. 2 tests passed. Okie dokie. Sounds good to me. Alright, let's see. Add to head. Now we need to add to tail. Actually, before we add to the tail, I think we should check in the add to head if when we add to the head, if the length is 0 before we add to the head, then it should also add it to the tail, because in the list, if there's only one item in the list, then the head is the tail and the tail is the head. They're the same thing. They're the same node. So we need to check that. Self dot assert true, assert equal. Let's see what assert equal shows us. Self dot DLL dot head and node. That's wrong. Self dot DLL dot tail and node. Run. It says none does not equal node. Yeah, I can see that. None does not equal node. Okay. So tail is none. So that means we need to do some checks. What we're going to say is if not self.head, if not self.head, then self.tail equals node, and then self.head equals node, and then self.length plus equals 1. I think that'll solve that. Alright, ran 2 tests. Okay, nice. Okay. Now, I'm going to move this length down 1, and it still passes. Okay, cool. Just to make sure that it didn't, which I know that it's not, because we're only incrementing 1 time. But just to be on the safe side, it's there. We checked it. All right, let's see. Add to head. So what did we do? We created a node. We added it to the head. We checked if the head existed. We checked if the tail is equal to the... let's actually change this to self.dll.head. Just make sure those are equal. All right, we checked if the tail is equal to the head. And then we made sure the length was only incremented by 1. Okay, so now if there's an item there and we're adding to the head, there's already a head, what happens? Well, if we say node 2 equals new node, node 2 equals new node, and then self.dll.add to head, and then we add node 2. Well, we need to check the same thing. Self.assert true, assert equal, self.dll.head is equal to node 2, self.assert false, self.dll.head, and self self.dll.tell, right? So what are we doing? We're creating another node, we're adding it to the head, we're checking that the new head is equal to the new node, and then we're checking that the head and the tail are different. And then we also need to check assert equal, check the length. Self.dll.length and 2. All right, let's run it and see what happens. So node object is not false on line 33. Assert false, self.dll.tell. Don't know what just happened. So it's saying that this is true. It's not false. So oh, well, that's why, because I had to do that. Let's run it again. Oh, ran 2 tests okay. Would you look at that? Why did it pass? It passed because we created a new node. This says if not self.head, so if a head does already exist, then just go ahead and set the node equal to the new node equal to the head equal to the new node, and then increment by 1. So we had already covered that case. So that looks good. This is just a, I mean, I guess it's not necessarily needed, but it's there. All right. Let's see. We don't have any next or anything like that. So I'm thinking that we get through the basic list methods, the basic portions of the list methods, like adding it to the head, adding it to the tail, deleting it from the head, deleting it from the tail, getting all that stuff to work, and then we'll focus on the more complicating logic, which is the updating the nodes themselves to reference each other. All right, so def test add to tail self, and we'll pretty much do the same thing here, except all tail. Control V, take head, we're going to change that to tail everywhere, tail, and then all of the tails, shoot, let me mark the ones that are supposed to be head. So all the tails are going to be head, I think. Let's see, add to head, this would be add to tail, assert true, tail, assert equal, DLL, tail, so this should start new, the head and the tail should be equal. Alright, so we'll just go down here, we'll just change them manually. We'll say tail, assert true, self.dll.tail, that's supposed to be true, assert equal, these should be equal, assert equal, that should be right, node 2 dll dot add to tail, if you hear the dogs again, assert equal self.dll dot head, and node 2, this should be tail, tail, and then assert false, the head should not equal the tail, and assert equal, it should be 2. So let's run it and see what happens. It has no attribute add to tail, so let's create it. It's gonna be pretty much a duplicate of this again. Let's, don't know what just happened. All right, add to tail, change all these, tail, if not self.tail, self.tail equals node, this should be head, self.head, so if you add it to the tail for some reason, It should update the head if there's not already a tail, and then self.tail equals node self.length plus equals 1. Sounds good. All right, let's test them and see what happens now. Ran 3 tests, okay. All right, so we have the add to tail working. Now what do we need? Add to tail, add to head. We got that. So add to head, add to tail, remove node from head. Okay. Now we're going to remove from head. Test, remove from, we'll just say remove head, self. All right. Self.dll.remove head. There is no, I have to create a node first. I'm not going to create a node. I'm just going to say self.dll.add to head. And I'm going to do node. I'm just going to create a node inside here because I'm going to copy that down. I'm going to make sure that self.assert equal self.dll.length. We're going to check the length, make sure the length is 3, and let's make sure that's working properly. Ran 4 tests, okay, so everything's looking good. So the length is 3. Let's see. The length is 3. I guess now we can remove. So self.dll.remove head. We'll just call it, and then self.assert equal self.dll.length. Should be 2 now. And we're just going to duplicate this. This should be 1, and this should be 0. Alright, let's run it. Ran 4 tests, failed. Doesn't have attribute remove head, so let's do that. Node DLL. Def remove. Got a notification. Right. Remove head self. All right, and let's see. Remove head self. Would you say self dot head equals none in this case because we don't have any next or prevs on our nodes. So that means, because I don't want to do that yet, these are still going to fail because self.length minus equals 1. All right. And actually, if we call this again and the head is already none, then it's still gonna decrement the length. So length will end up being -1, -2. We don't want that, so we want to say if self.head and then do this. We're gonna just make sure that there's a head. Run. Ran 4 tests. 2 does not equal 1. Oh, yeah, that's what I was talking about. Okay. The reason that that's not working is because I don't have a reference to the next node that's connected to the head. So if I remove the head, I don't have a reference to the head's next to be able to assign that next node to head. Right now, this there's nodes being created. The only thing that we know is that there's been however many nodes created because of the length, but we don't even know what those nodes are. We can't find them. We can't do anything. We can find the head and the tail. That's about it. Any other node in between that, the list was 20 in length. We'd only know 2 nodes, and we wouldn't be able to find the other ones right now anyway. We'll get to that. So what I'm just going to do is save this for later. I'm going to do that. That should pass that, and it does. I'm going to save that for later. And now we're going to do the same thing, but remove tail, and this would be the same exact thing, I believe. So remove tail, boom, 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 tail, like that. Add to tail, and this should do the same thing, except it should fail because I don't have a remove tail. Go to DLL, remove head, copy this down. It's the exact same thing. Call this tail. Actually, I wanted to change all of them. If there's a tail, then tail equals none. Otherwise, and minimize, decrement the length, and otherwise don't do anything because there's no tail. This should pass. Ran 5 tests, okay. Awesome. Alright, so we removed head, we removed the tail. Let's get rid of those. Now we want to delete a node. We can't do that yet because we don't have any reference to the prev and next. In order to delete a node, the way you do that is here's 2. Okay, so we got 3 nodes. We got, this one, this one, this one. This one has a reference to the next and the prev, right? So what we do is we take this node's prev, we take this node's next, and assign it to this node's next. So this node will be assigned to this node, and then this node we will assign its prev to this node's prev. So this node will be assigned to this node. This node will still exist, but it'll be just floating around in the abyss, and then these nodes will be referencing each other, so therefore essentially deleting this node. So that's what we would have to give the node some functionality for this. The same for the insert after and insert before. So that brings us to our next point. Now we've already done all the basic stuff here. Now what we want to do is give the node logic, because if we come up to add to head, when we add, so here we want to, not in this one, in this one we want to make sure that so we have the assert equal, the head is equal to the node that we just created, which of course it should be. The head is equal to the tail. Okay. I was getting confused for a second. I'm like, why would the head be equal to the tail? The head is not equal to the tail. And then the length is 2. Instead of checking that the head is not equal to the tail, what we want to do is we want to assert equal, and then we want to say the head's next is the self.tail, right? And then we also want to say, oh my Jesus Lord. Okay, and then we also want to say that the head is equal to the tail's prev. So we want to make sure that those are doing exactly what they're supposed to do. And we get an error, node object has no attribute next. So let's give them a next. Def init, like that. reference to self. We will give it a value, a prev, and a next. These will equal none. This prev will equal none, and the value will have to have a value. So let's go ahead and code that up. Self.value equals value, self.prev equals prev, self.next equals next. All right. Ran 5 tests, missing one required positional argument, the value. Okay, so we got to pass values into these now. So we'll say 1, 2. Okay. Now let's see what happens. Technical difficulties. Knocked over my mic. All right, cool. Okay, so what's the problem? It says init missing one required positional value. This is line 58, of course. Gotta add value in here. We'll say 1, 2, 3. Save that. Run. Missing one required positional 46. Same thing. 1, 2, 3. Save. Run it. Missing one required. Jeez Louise. 34. This is good. This is good. 1, 2. All right. Run it again. Missing one required positional argument. Second. Second. What's a second? Assert equal second. Assert equal missing one required. Oh, okay, gotcha. 29. I did assert equal. This should be assert true, but I can get rid of this is. And run it. Line 29. None does not equal node. So it says that the head's next does not equal the tail. And the reason for that is because when we added to the head, we didn't assign it. So if not self.head, self.tail equals node. But we also have to say self.head.next self.head.next equals self.tail. And then also self.tail.prev equals self.head. Right? Makes sense? So if there's not a head, that means we're adding one item. Okay, that's wrong. That's wrong. If there is already a head, then we need to say the head equals the node. And I think we would have to add this in an else logic. Otherwise, it'll do it always. And we don't want it to do it if there is if there's only one item. So else if not self.head, so if there is no head, then add that to the tail. Otherwise, if there is a head, that means there is a tail. So we will say what we're wanting to do is the current head's next prev is supposed to be assigned to the current head, and the current head's next needs to be assigned to the node's next. Okay, so here I'll write it and then I'll explain it. It'd be easier for you to see it while I explain it. So if there is already a head, it means there's a tail. Then we will say self dot, let's see, I'm trying to think where I need to add this self dot head equals node. I'm thinking this needs to be at the top. And then we could say self.tell equals self.head, like that, just to make that a little more understandable. And then we would say self.head.next.prev equals self.head, and self.head.next wait a second, no, that's not right either. Self.head equals node. Let's do cur equals self.head. Self.head equals node. Now we can say self.head.next. Self.head cur.prev equals self.head, and then self.head.next equals cur. Cur for current, which is what the current head was. Let's see, does that make sense? If not, self.head, self.tell equals self.head, else the currents.prev, the current, if there's only one item on there, the current would be the tail, which would also be the head. So I think that works. I think that works. Let's run it and see what happens. Cur.prev equals self.head attribute none type object has no attribute prev. Ah, got you. That's because I'm doing this before I add anything to the head. So if there isn't already a head, this isn't going to work. This needs to go down here. And maybe get rid of this else. Let's see what that does. See what that does. Cur.prev none type object. Interesting. Okay, let's rethink this. Let's delete it. All right, so we have one node. Okay, we have one node. Let's completely forget about the self.head equals self.tell, all that stuff. Oh, we can't do that anyway because this does have to be node. It does have to be node now because this is at the top. If not, self.head, self.tell equals node. Otherwise, I'm thinking, do I have to add self.head equals node up there too? Because I guess we could do that, and then if we figure out a better way to do it, then we'll change it. So they both equal node, and then we'll just add an else in here. Drinks getting water everywhere. We'll just add an else in here, and the else will say, okay, so we have a tell, and we have a head. The head is, say for example, 5. The head's next is none. Yeah, because if there's only one thing in there, the head and the tell are the same thing. Whatever the head is, we want to keep it the way that it is, because if it's the tail also, they're the same node, then if we change the next of that node, then that means the tail will have a next, and that's not right. So we have to do what? We have to change just the list head, and then we have to change the prev only, I think, and then the current heads next. So how would we do that? Let's do the same method we were doing just a second ago. So we're assuming that we do have a head, so we'll say cur equals self.head, and then we will say self.head equals node, and then self. What if we just say node.next equals cur, and cur.prev equals node, and then self.head equals node. Self.head equals node. I feel like that makes sense to me. Hey, missing one required positional argument, line 30. Assert equal. I did this again. So that worked. That worked. That made it pass. And then now that just made that pass. Awesome. So now, what I was talking about before, I wonder if I had to put self.head in here. I don't, because I manipulated the node itself instead of storing the node and then manipulating the head. I manipulated the node itself, so I can get rid of self.head equals node, and I can take this outside of that else block. And then I can delete these like that and make it look a little better. So let's see. Cur equals self.head, node.next equals cur, cur.prev equals node, node.next equals cur, cur.prev equals node, self.head equals node. Okay, cool. Cool. Let me just run this again, just double check, never know. Awesome. Now to add to tell, it's pretty much the same thing. We're going to change the same stuff. So we have node 2 here. We want to take these, copy them, replace this, and then we want to say tell equal, assert equal self.head.next. This would be self.tell.prev. So there's only 2. Yeah, we can do the same thing. Is self.dll.tell. And then assert equal self.dll.head. Self.dll.tell.prev. Same thing, and then yeah, same thing. Okay, so they're the same thing, I guess. Line 42 is not equal. This is add to tell. Add to tell. This would be the same thing. If not, self.tell, self.head equals node, and then we need an else. This else will say cur equals self.tell, and then we will say node.prev equals cur, and cur.next equals node, and then self.tell equals node, self.linked plus equals 1. Stuttering over here. Let's run it and see what happens. Yeah, they passed. Nice. All right, so now we can add to tell, we can add to the head, and it'll update the nodes like it should. Let's see, test, remove head. Okay, now this is where we can uncomment these. run that. It should fail. It says the length is not equal to 1, 2 does not equal 1, which is this one, because we remove from head, but when we remove from the head, we're supposed to set, we don't just set the head equal to none. So if self.head, and then we would say if self.head.next, then we would say self.head.next.prev equals self equals none. Actually, we would just say self.head equals self.head.next, like that, and then self.head.prev equals none. So if there is a next, then we say we set the head to the next of it, and then we set the current head's prev equal to nothing, because there should be nothing previous to that. And then so that's assuming that there's a next. If there's not, so we would have an else. If there's not, then self.head equals none, which I already have it right there, and I'm typing it again, but who cares? Like that. And then this would be inside this block here, decrementing by 1, like it's supposed to. Now let's see what happens if I run it and it passes. Beautiful. Beautiful, beautiful, beautiful. Remove from head. So we're checking if the length is right. Let's check if the tail has a storage. Self.assert false. Self. Let's think. If there's only one item and you remove it from the head, it should remove it from the tail as well. So self.dll.tell, that should be false, and node object is not false. So tail's not being deleted. So if there's a next, do all this. If there's not a next, self.head equals none, self.tell equals none, like that. Because there's only one thing. You remove that node from the list, there is no head and there is no tail. Now it passes, and then we can do the same thing with the remove from tail. It's essentially the same. Let's add this extra thing here, except this will be head. Let's save it, run it. 2 does not equal 1, same line, 67, and we remove from tail, and then we can pretty much just copy this whole thing again. If self.prev, self.tell.prev, self.tell equals self.tell.prev, self.tell.next equals none, just like that. And then we have an else, self.tell equals none, and whoa, what just happened? Oh, I moved things. Self.tell equals none, and self.head equals none, and then the length decrements by 1. And they all pass. Nice. So those were the removes. Remove from tail, remove head. Now we have now we can do delete node because we have a next and a prev for our nodes. And these have next and prevs. We don't necessarily have to have any methods attached to this, but it makes things a little bit cleaner when you do. Because here, for example, let's see, add to tail. Like with the node, I can just say this current node, its prev is its next, and just all kinds of stuff. It makes it a little easier to do that kind of stuff. But anyway, let's do delete node, def test delete node self. All right, so we need to add a node. So self.add to, we'll add to tail node. We're going to need a reference to this node, so we're going to say deleting node equals node. We're going to say 10. Self.test.add to tail deleting node. All right, so we added that to the tail. Now we're going to add, let's see, now we're going to add to the head, add to head. We're just going to add a random node to the head. This would be node 1, and then add another one to the tail. This is going to be a random node 2. Okay, now self.assert equal self.dll.length should equal 3. Deleting node node 10 self.test.add to tail deleting node self.test.add to tail. So now it should be equal to 3. We're just going to run that and test it just to make sure. Test add to tail deleting node. Test add to tail takes 1 positional argument. Oh, I added the test part. Shouldn't have done that. Let's get rid of those. Oh, and it's self.dll.add to tail. All right, all tests passed. So now our length is 3. Now we want to delete a node, any node, from the list. So in our case, this node is the center of the list because I added one to the head and I added one to the tail. It's the center of the list. And we could say self.dll.delete deleting node, right? And then we would test self.assert false. So I guess we would need a find node method. We won't do that right now. We're just going to do length. Assert equal self.dll.length is equal to 2. This should fail. DLL object has no attribute delete. Let's change it to delete node. Delete node. Let's go to DLL. Bam, bam. Def delete node self node. All right, now this is where the node methods would come in handy, because then I could just, if they're already created, I could just say node.delete, and then it'll just completely wipe everything out. But in this case, I'm gonna have to check if, so I'm gonna have to say if node is self.head pass elif node is self.tell pass else if it's neither then pass. And I think I need to say if node is self.head and node is self.tell pass. This would be an elif. So if node is self.head and node is self.tell, if it's both of them, then I'm just going to call one of these other methods, remove from head or whatever, and then it's just going to remove both of them. Otherwise, if it's the head, I'll call remove from head. If it's tail, I'll call remove from tail. Otherwise, I'll call the delete and delete. Just, you know, connect them in the ways they're supposed to be connected. So let's do if node is self.head and node is self.tell, then we would just say self.remove head like that. That should fix that problem. This self.remove head, that should fix that problem because yeah. And then self.remove tail, that should fix that problem. And then this is where I would normally do node dot delete, and then it would do it for it, but I can do the logic and then add that later. Let's see. The node would have a previous and a next, so I just do that here. I would say node dot prev dot next equals node dot next dot node dot prev dot next equals node dot next node dot next dot prev equals node dot prev, and I just say node dot value equals none just to get rid of that. Don't know if it even does anything. And then regardless, there's going to be a element removed, so we self dot length minus equals 1. Let's run the test. Ran 6 tests. Okay, nice. Nice. So deleting the node worked. And then let's try deleting another one. This would be leave 1. Save. Ran 6 tests. Okay. And then now we can say that self dot assert equal, the head and the tail should be the same. Self dot dll dot head and self dot dll dot tail. All right, and so it says node object at node that, so they're not equal. They're not equal for some reason. See if we can debug this. Let's see, delete node. If node is the head and the tail, remove. So let's print self.head.value, self.tail.value. This one, print self.head.value, self.head.next.value. Here, print self.tell.value, self.tell.prev.value, and then otherwise let's just try this and see what happens. Oh, wrong file. It didn't even print anything. Line 82. So let's get rid of this. Save it. So we have 3. We delete a node. Now we have 2. We delete a node. Now we have 1. That's right. So if we only have 1 node, then self.head, self.dll.head is self.dll.tell. They should be the same thing. And they're not. False is not true. So somewhere I didn't cover something. So we give it a node. If the node is self.head and the node is self.tell, meaning we only have 1 item, then remove head. If the node is self.head, then remove head. Let's see what happens. So we have this. We have assert equal the length. We say, oh, well, that's why. Because I deleted the node, I can't delete the node again, right? We have 3. This is in the middle. So now it's 2. And then this node should be gone. This node should be gone. I'm thinking when I delete the node here, I say self.head equals node. I did all this stuff, but no, not that. Where is it? Remove. Yeah, remove head. Interesting. So if they're the same, if the node is the head, if the node is the tail, otherwise node.prev.next equals node.next, node.next.prev equals node.prev, and node.value equals none. But I should also do node.prev equals none and node.next equals none to make sure that it can't reference anything. That's the wrong file. None type object has no attribute next. Okay, good. So now we're getting somewhere. 58. Is that line 58? Line 80. Line 80. Delete node. Deleting node. This node doesn't have anything to delete. We can't delete that node. We have to delete self.dll.head now. We have to delete that node. There's 2. Now there's only 1. And 0 does not equal 1. Line 81. Assert equal self.dll.length is 1. Self.dll.length is 2. If I delete the head, it should be 1. Because here I said if node is head, and I'm not even getting these prints anywhere. Oh, there we are. 1, 2. Let's see. How long have we been streaming? Not even 2 hours yet. Surprised. Okay, so let's see. If node is self.head, self.remove head, inside remove head. We're doing the same thing here. We could probably just say if it's that or if it's just head. Or I could just say if self.length equals 1, then do that. Else, if node is self.head, then do that. If it's equal to 1, then self.head equals none. Self.tell equals none. I'm going to delete these prints because they're not really telling me anything. Node is self.head, self.remove head. That you would think that would make sense. You would think that would work. If self.head, self.head.next. So if there's 2, the next should be, let's see, there's 2, self.assert equal self.dll.head.next and self.dll.tell. Okay. Get out of my face. Line 82. Let me get rid of these. Run. Okay, so that worked. So the head's next is the tail. So now if I delete the head, it should trigger this one. And then oh wait. I did this, but I didn't wait, no, yeah, because it would still be the head. That wouldn't matter. Delete self.head. Then I would say this. And that's correct. So self.head is self.tell. But now it's saying that, oh, I know why. Duh. In these, when I remove head and when I remove tail, so I'm just going to leave remove head here, self.remove head, because they already have a decrement on them. This needs to be in the else there. So now that should work. There we go. Perfect. Perfection. Perfecto. Mundo dundo. Alright, so we tested deleting the nodes. That works. Length is 1. I guess we can get it back down to 0. Self.dll. Let's just copy and paste one of these. Deletes the head. And then this should be 0. And then we should be able to say assert false. Is it true? We'll just change it to false. Assert false. We say self.dll.head and self.dll.tail. There we go. Awesome. So there's no head, there's no tail. The length is 0. Everything's back down like it should be. So we deleted the node. Now we need to insert after. So we in order to insert after, you have to know what the node is. If there's a node with 10 items in it and you're wanting the very middle one, you have to be able to find that middle node, whatever the node is. So how would we do that? How would we find what that node is? Let's see. We could do a search and then search for what? A value? Search for some value. We could search this. I wish I had more people watching so they could help me figure out what to do. But search for a value, search for if you already know what the node is, search for that node. No, because then you could just, if you knew what the node was. So I guess we would just do a search and then search for the value. And if the value is found, then we would either insert before or insert after, whichever method we're using. But we have to create that search functionality first. So let's do that. Let's create a test for it. How's the search going to look? How's it going to feel? How's it going to whatever? Def test find node self. Okay, now this is where it's going to get a little hairy. I know in Python there's a way to do, I mean, I could do like random blah 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 all this stuff, but actually I'm just gonna self.add self.dll.add to head. I'm just gonna add a bunch of nodes like this, like that, and I'm just gonna pop, 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 pop. It's messy, but who cares? This would be 2, this would be 3, 4, 5, 6, 7, 8. Alright, so we add a bunch of nodes. You know what, actually I want to experiment with this. So for I in range 10. For I in range 10, I think I could single line this. Self.dll.add to head node, and then isn't there like a random thing? Let me check. Python math random number. Generate random numbers using Python. This article I'll explain usage of random module in Python. As the name implies, it allows you to generate random numbers, random, min, max. Okay, cool. So we would just import random. That gave me some details on it too, huh? Random variable generators, integers, uniform within range, sequences, pick random element, pick random sample, blah, 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 not important. Okay. Import random. And we will generate a random from 1 to 20. Sound good? And then we want to say self.assert equal self.dll.length is equal to 19, I think. Ran 7 tests failed. Module object is not callable. I thought it just said I could do that. Random between 0 and 1, but there are other like function. Oh, rand int. Rand range max. That's what I want. Rand range. So let's do rand range 20, right? Something like that. I don't know. Rand range max. Random.random returns the next random float in the range 0 to 1. Random.randint. Okay. That's what it is. I don't know why I was thinking that I could just do it that way. Rand range start stop rand int return random integer in range including both endpoints. Rand int 1 20. I don't know why it's giving me an error. Maybe it's a accident. So now it says including, so now we should have 20. Oh wait, no, range 10. I'm an idiot. Yeah, range 10. The length is going to be 10. If it's inclusive, I have no idea. Aha, awesome. Okay, so now we have a bunch of junk, pretty much. Why is this giving me unused variable I? I think I have to say, I think I have to put a variable, don't I? Yeah, I have to put a variable. Yeah, I do. Okay. I could probably just do that. Can I? For in range. Does that work? Yes, it does. Awesome. Yeah. And it's not giving me a thing either, so it's like it's not throwing an error or anything like that. It's weird. Okay, let's see. Test find node. So we have a bunch of nodes in there now, randomly kind of generated in there. There's only one problem. Now that they're randomly generated in there, I don't really know what node to grab because I don't know what nodes are in there. Don't really know what nodes are in there. And it'd just be a game of back and forth if I tried to like guess a node and then it didn't work because there wasn't a node and I just kept getting no node, no node, no node. I mean, that wouldn't really make sense. So let's try something else. I don't think it's gonna work doing it that way, randomly generating them. Instead of randomly generating them, I'll just I thought randomly generating them would have been cool, but I guess not. I'll just pass an I here. Make sure everything's good. We are missing a parentheses, and I don't need random anymore up here. Just get rid of that. I don't know anything about Python much, less I speak English, but you have helped me to solve certain HackerRank problems. Ah, awesome. Well, I'm glad I was able to help. Glad I was able to help. Makes me feel better. Let's see. Okay, so we have nodes ranging to 10. And let's see. I guess we could just find 5. Self.assert equals self.dll.length 10. We want to say self.dll.find node find node, and then we're just going to pass in a value, and we're going to find a node with that value. I guess that would be a decent use case. I have no idea. And then if we find the node with that value, we should be able to... So when we call that method, it should return that node, and then we use that node to do the inserting after or inserting before. So that's what we're going to do. So we're going to actually say self.assert true self.assert true. I guess self.assert true, make sure that we're returning something. I guess that would work. I don't really know how to test that, to be honest. Self.assert true, self.dll.find node. Let's see. We're going to run that. It's going to fail because we don't have a find node. I guess we'll just start with that. We'll find the node. We can worry about that other stuff later. Got a message. Okay. All right. So let's def. What was it? What did I call it? Find node. Find node. This will take self and then the value that we're looking for, and now we're gonna have to loop through the linked list. So this is gonna, I think this is gonna require a do while loop, so, or a while whatever, do something. Let's look up the syntax because I'm not entirely sure. Let's see, do while Python. Misspelled that. Python doesn't have a do while, but we can create a program like this. Is there a while loop? While loop Python. What is while loop in Python? While test expression, yada yada. While loop in Python is used to iterate. Okay. So I just need to know what the syntax was. So while we actually will say current equals self.head. We're going to have to start with the head. We could start with the tail, but I mean, if it was a random list of nodes, it doesn't really matter where you start, because you can only go to the next one. You can't skip or anything like that. So current equals self.head. Let's see. Let's say while current.next, while current.next, if current.next dot value, current.next dot value is value. If current.next.value is value, then we want to return current.next. Else, we want to say current equals current.next. All right. And then, so let's see, return current.next. If you get to the end, then you just return, I guess, return none. I guess we could do that. Let's see what happens. Ah, it passed. Awesome. So we returned something. And it wasn't none. But if I pass in something that doesn't exist, like an 11, it should fail. Yeah, there we go. None is not true. Awesome, 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 awesome. So we're going to pass that, and then we're also going to make sure that that test is being checked, even though we just checked it. We're going to make sure it's in the code. False. This should be 11. Run the test, and it passed. Awesome. So now we have a find node method that we can use that it will return a value. So now we can create an insert after or insert before. So we'll start with insert after. We want to be able to say insert let's see, test insert after self. All right, so what do we want to do? Insert after, we want to, obviously we got to create a node, or we got to create a bunch of nodes. So let's copy this, paste this, create a bunch of nodes, range to 10. We want to make sure that the length, everything's right, even though we know that it is because we've already ran those tests, just to be sure. Okay, find node 5. Now we want to say self.dll. We want to create a node, so we'll say inserting node equals node, and we'll make it 100. And then we will say self.dll.insert after. We'll pass in the inserting node, and then it'll insert after some node value. Insert after, let's see, what, after a 5, I guess. Self.dll.insert after inserting node 5, and then we can assert equal. We can say self.dll.length is equal to 11 now because we just added one. And it failed because we don't have a insert after method. We can create that real easy. Def insert after self. We passed in the node and a value to find. Let's see. So we want to insert after. We have the node, and so we'll say what would we call it? Insertion node. Bro, I know someone famous. Who's famous? Who's the famous person that you know? There's a 20 second delay, so it's going to take a minute for me to see your messages, by the way. Insert after. No. Insertion point is what I want to call it. Insertion point equals self.find node, and then we're going to find the node with the value. We're going to say if insertion point, that is JavaScript, not Python. If insertion point, then we want to say insertion point dot next dot prev equals node. Insertion point dot next. Actually, we're gonna assign the nodes values first. Node dot next equals insertion point dot next. Nodes dot next equals insertion points dot next, and the node, as we're inserting after, yeah, and then the node dot prev equals the insertion point dot prev. I went to high school with this dude. Oh, you talking about me, bro? Talking about me? He's got an Instagram. Go follow his Instagram if anybody's watching this. Dude, I'm not famous, bro. I barely have any subscribers. Literally, I'm surprised 2 people even showed up to this live stream. Barely anybody ever shows up to this stuff. But I like doing it, so I do it. Node.prev equals insertion point.prev. insertion point equals insertion point. All right, now insertion point dot next, or actually now we could say node dot next dot prev equals node, and node dot prev dot next equals node. Perfect. All right, so if insertion point else we want to return none. Let's see. So insert after insertion point equals self.find node value. If insertion point node.next equals insertion point dot next node.prev equals insertion point node.next.prev equals node, and node.prev.next equals node. That looks right to me. And then so if insertion point's not true, if it's none, then this function will return none. So let's save that. Let's see, self.dll.insert after inserting node. The length should be 1. So 5 should exist. So this should pass. And it didn't pass. 10 does not equal 11. And there's a reason for that. And the reason is I forgot to increment. So insert after anytime we're inserting. Let me see real quick. What do we have? Add to tail, add to head. Okay, yeah. We need to say self.length plus equals 1. Gotta increment. Gotta increment. Now it should pass. Boom. Ran 8 tests, passed. Okay. Awesome. Awesome. But now what happens if we try to insert let's see, it's equal. We want to say insertion node. So that should not return anything. I mean, I guess I could because now it's not a void method. It actually returns something. So I guess, I mean, I don't really know how Python deals with that, but I guess I'll just return true from that just to cover that case. Self. Let's see. Yeah. Self dot assert true, and then. Well, I really don't want to insert something else there, because I got to create another node. Self.dll.insert after inserting node and 5. I guess I could return the node instead of returning true. I could just return the node that that I found. So it would be the node.prev. So I could return node.prev, and that way I can say let's see, self.dll.insert after. I can say, I could do insertion point here. Insertion point equals that stuff. And then I can say assert true, insertion point, and insertion point dot next is inserting node. That should pass. Let me save this one. Oh yeah, I just updated that, so that should be fine. And ran 8 tests. Okay, nice. This is still trying to tell me instance of int has no next number. So why didn't it throw an error right here if that's the case? Let me just try saving that again. See if that's still giving me that issue. Instance of int has no next number. Self.assert true. Insertion point equals self.dll.insert after inserting node. 5. So it's debug time now. Now we got to debug this stuff. Insertion point, return node.prev. Node.prev equals the insertion point. Self.find node value. Find node. Return current.next. Let's see. Wait, this find node, what did I do here? Assert true, find node 5, assert false, find node 11. Okay, so I was just making sure that and it's returning something. So I can say, found node equals, I'll just do it here. Let's say found node equals self.assert true. That doesn't need to be there. Found node equals that, and then we could say self.assert equal found node dot value should be 5. So let me get that out of the way. Okay, cool. All right, so that worked. Nice. Let me do this and run this again and see what the issue was. It's saying okay, but this is giving me an error saying instance of int has no next member. So maybe I need to break these up. Maybe there's some weird thing going on. Yeah, let's see. Self.assert true, insertion point, and insertion point.next is inserting node. Insertion point equals self.dll.insert after 5. So insertion point should be, the value should be 5. Let's check that. Dot value, I guess, is 5. It's still giving me that weird thing. Ran 8 tests, okay. Did you mean equals equals? I did mean equals equals. Run it again, 8 tests, okay. It's still giving me this weird int has no value member. I don't know where that's coming from. I mean, it's not throwing any issues with my tests, but it's just weird that it's doing that. Self assert true, insertion point, self.dll.insert after inserting node. Insert after. We have an insertion point equals that. That's a node. If insertion point, I guess, is not none, which, I mean, it should, it's the same thing. I'm just putting that just in case. You never know. You never know. Node.next equals insertion point.next. Node.prev equals insertion point. That's right. That puts it right in the middle. Then node.next.prev equals node, and node.prev.next equals node. And then that points them to the node. And then we want to node.prev. What if I just return insertion point? Should be the same thing though. Should be the same thing. Do I still get that error? It's not looking like I'm getting that error now. Awesome. So that must have been the issue. I don't know why that would have thrown an issue, but I guess I'll respond to this chat in the chat. even though he's already gone. I went to high school with this dude. What's up? What's up, brother? All right. Let's see. So where are we at now? Insertion point equals self.dll that insert after inserting node 5. Self.assert true insertion point dot value equals 5. So that's right. It's good. Self.assert equal self.dll that length equals 11. That's good. There was another part in there that I completely forgot about. Completely forgot about testing. I had it in there and I deleted it. And now I don't even know what it was. Let's see. Insertion point self.dll that insert after inserting node 5. Dang, what was that? It was important too. Oh, I want to make sure that the inserting node is the insertion points next. Yeah, that's what I want to do. Okay. Self.assert true. Inserting point dot next is I'll do equals. I'll do equals. Equals self dot no inserting point dot next and insertion point inserting node. See if that passes. Yeah, buddy. Yeah, buddy, boy. It worked. Awesome. Okay, so I guess we could also make sure that the inserting nodes next prev is inserting node. So we'll make sure that's the case as well. Is equal. This will be inserting node dot next dot prev is equal to inserting node. Yep. That's what we want to see, and everything's good. Everything's Gucci. All right, we finished insert after. Now we want to do insert before. And it should be pretty much the same. I mean, just thinking about it off the top of my head, it should be pretty much the same, except for everything's pretty much backwards now. Voice cracked a little bit. So let's see. So we have our node list created. Assert equal the length, everything. We're checking everything again. Inserting node. We are right here. Insert after. We want to change all these afters to befores. Insert before. And then inserting node 5, and we want to make sure that, let's see, assert true insertion point dot value equals 5. Assert equal self dot length is 11. Self dot assert equal insertion point dot prev is the inserting node, and dot prev dot next is the inserting node. These are going to fail because we don't have it, of course. We got to create this insert before method. So let's do that. Def insert before. It's going to be the exact same way. I mean, I could probably just copy and paste this and do the same thing, change a couple things. So we're going to do that. Boom. Boom, 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 boom. Just like that. All right, let's check it. Insertion point equals self.find node value if insertion point is not none. Node.next, this should be node.prev, right? No, node.next. let me think for a second. So here's the node that so we got our list here. We're going to use these here. Here's the node. This is the before. We're putting the node here, so this node's next needs to be referencing this node. So it should just be insertion point, and then the node's prev should be the insertion point dot prev, and then the node's next prev should be the node, and then the node's prev next should be the node, because the node prev is the insertion point dot prev. The length should be incremented by 1, and then we return the insertion point and return none if we don't find one. And that's another thing that I got to test that I forgot to test. Everything passed. Awesome. Okay, so now that's what I want to test. If we try to insert, let's see, if we try to insert at a value that doesn't exist, so insert at value that doesn't exist. That way I kind of break it up a little bit. We're going to do the same thing here. Self dot insert after, except it's going to be insert before. No, it's going to be insert after. Okay. Boom. This is going to equate to false. So self dot assert false, and like that. And then we got to put a value that doesn't exist. So 11. So that should work. That should pass. Actually, we're gonna make it fail first. Boom. Wait, how did that pass? Self.dll.insert after inserting node 10 5. Okay, there we go. Node is not false. So I guess there wasn't a 10. I guess this is exclusive, not inclusive, but there's no way. Oh, wait, unless it starts at 0. Okay. So it must start at 0 and then go up to 9. That's what that was. So 10 didn't exist. That's why it was true. 10. Yeah, okay, cool. Coolio. If I do true, it should tell me why exactly. Right here, none is not true because it doesn't exist. Which is pretty Gucci. And then let's do the same thing down here. Just copy and paste these. Down, blah, 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 all the way down. Insert at value that doesn't exist. Self.assert, insert before 10. 10 doesn't exist. Should pass. Okay, if I make this true, it should fail. And it failed. Nice. None is not true. Awesome. Awesome possum. So all that works. Coolio. How long have I been streaming? 2 hours, a little over 2 hours. Alright, well, I'm going to cut it here. Doesn't look like anybody's still watching, but yeah, I'm going to cut it here and pick up, I guess, tomorrow here at this after this test insert before. Let's make a plan of what we want to do tomorrow. So we already did this insert before, so that's great. Works nice. Let's do a why don't we do a print? Print all of the nodes in the list. So print all nodes in list. Have a nice little print that'll show the node with the arrows pointing to each and all that stuff. Let's do a swap nodes, swap 2 nodes. Actually, we'll do swap with next, and then we'll do a swap with prev. let's see, and then actually before this, I want to set up the node methods. I want to set up the node methods. So tomorrow's going to be the advanced stuff. Right now, what we worked on was the test the DLL was created. We tested adding to the head, adding to the tail, removing the head, removing the tail, deleting a node in place, finding a node by value. So actually, I'll just add some docstring since I'm closing up here. Find node by value, test insert after, insert node after node by value, like that. Wait, yeah, after. And this will be the same. Boom. We'll move this down here and we'll say before. Deleting node. This will be delete node in place, like so. Remove tail node, or delete tail node, whatever you want to call it. Remove head node, like that. Add node to tail. Add node to head. I mean, obviously, you know that the name of the method kind of speaks for itself, but oh well, who cares? The linked list has been created. Okay, cool. So we have these. Now tomorrow we are going to set up the node methods here because currently the node has no methods. So far all the logic's done in the doubly linked list class, and then we're going to print all nodes in the list. That's going to be a nice little visual kind of thing for visual, like for, I guess, you know, like, oh, I'm grabbing the 5 in the middle of the list and you want a visual of it. That's what that's going to be. I guess it's going to look like something like it'll be like an arrow with a number, and then this will have an arrow this way, and this will have an arrow this way, and this will be a number 5, you know, so on and so forth, kind of like that. And be like a 10 or whatever, and then like that. Okay, so that'll be how the printing will look, and then you just have a nice little visual there. Swap with the next. I mean, that's pretty self-explanatory. That'll be, you have a node here, say this is 4, and then you have a node here, say this is 10. Let's actually put another node here. This will be 1. Swapping with next will be pretty much, if I want to swap this 4, it'll put the 10 here and then put the 4 here, like that. That's what that'll be. Alright, and then swap with prev is the same thing as that, except, you know, obviously the previous one, I'm not going to draw that one out. I can draw it out. Who cares? I'll just copy this and paste it. This will be 1, this will be 10, and this will be a 4. Just like that. What else can we do? We could, if the list is composed of just integers, then we could sort the linked list. Sort list. We can reverse the list. Reverse list. This is a doubly linked list. That's going to be extremely easy. Sort the list, reverse the list. What else can we do? All right, well, we'll just leave it that way, and call this done for today. I think we did pretty good. We got quite a bit of tests here. The tests way heavily outweigh the actual code, but I think 94, yeah, 134. All right, yep. So we'll start working on the node class tomorrow. We'll start working on the more advanced stuff tomorrow. And I'm going to end this video here. Let me go back to my face. You can see in the background, I'm in the land of, what's it called? State of Decay. No, this is DayZ. I got this from DayZ. Love that game. But anyway, all right, peace out, whoever's here. I hope you guys enjoyed it. If you like this kind of stuff, subscribe, like, leave a comment. If you know anything else I can do with this linked list stuff, just put it in the comments. Let me know, and I will add it to the list, and I'll start working on that tomorrow. I like this test-driven development stuff. It's pretty cool. Testing everything, building the test, and then writing the code after the fact. It kind of gives you a more of a guidance toward the end result or whatever. But all right, yeah, I'm a head out and I guess surf the social media or something. I don't know. But peace out, everyone.